Hello and welcome to surface areas of spheres and hemispheres. We're still in three-dimensional shapes. This will wrap up all of surface area for our prism cylinders, pretty much every three-dimensional object that we are going to cover in this unit. And here we have spheres and hemispheres. These are pretty much our circles in 3 dimensions. And here we go. So surface area of a sphere is simply put 4 pi r squared. That is it, okay? So as long as you have the radius, you will be able to solve for the surface area of a sphere. So let's draw a sphere. Let's start with drawing a circle, and this is gonna be the fun part. How do you make this 3 dimensions? Well, if you start on the far left, and then you start drawing what looks like part of a oval, you're going to wrap around on the back side of it to complete the oval, but you're going to use a dotted line. And that will pretty much be what we like the equator of the Earth, okay? So the dotted line, obviously, you cannot see. The solid line you can see. And then we need to drop in the center of our sphere in the middle of this. I'm going to do this in red. And if we want to, we could go from end to end. And we could call this, for instance, well, that's our diameter. Okay, we still use radius, we still use diameter, which is the nice part. And it's as straightforward as it gets when it comes to surface area equations. So let's say the diameter of this is equal to 10 meters. Well, that means the radius is then equal to half of that. Radius would be equal to 5 meters. And then we could say, solve for, let's say we're gonna solve for the surface area of the sphere. Okay, so radius is equal to 5. That means we could take this equation. Surface area is then equal to 4 times pi times 5 squared. 5 squared is 25. Multiply that with the 4 and the pi, and we should get 100 pi, this is meters squared. Surface area of the sphere. Okay, and now we have it. So surface area, done. Now, hemispheres are slightly different. It's kind of interesting how this one works, okay? Because if you really think about a hemisphere, it's kind of like a snow globe. Hemisphere is half of a sphere, so let's define it. Hemisphere. A hemisphere is half of a sphere. Okay, so if we have half of a sphere, or if we have a snow globe, we actually only have half of it. So I'm going to draw half of a circle to start off with. That's a bad half circle, but here we go. That's a lot better. Then we're going to draw the front of it, but remember that oval. And then on the back side, we're going to draw the dotted line of the other part of this oval. We're going to draw the center of this, and as you can see, it's kind of like half of a dome, okay? And here we would have the radius. The radius could go in any direction. If we really wanted to make it go this way, we can. You should know that these two, even though they don't look like it, this would be congruent to this just because it is the radius. So if we have this hemisphere, half of the sphere, but surface area of a hemisphere is slightly different because you're not just cutting this in half as you would think. Yes, the hemisphere is half of a sphere, but the surface area changes because, as we discussed, a surface area is parts that you could actually physically touch, right? And if you think of a snow globe, yes, you could absolutely touch where around the snow globe where the glass is. But isn't it true that if you lift the snow globe up, you could actually touch the base of this? Yes, you can, because it's the bottom part. It's like a paintable surface. So what do? Well, the surface area would then be equal to the top half of a sphere plus the base. We now have a base of this, when the base of a circle is just pi r squared. So we're going to do that. We're going to take the equation, surface area of a hemisphere is equal to half of a sphere, half of the surface area of a hemisphere. So if you really, really think about this, we're going to take this 2 pi r squared, and we're going to take half of that, or I'm sorry, 4 pi r squared. I'm getting ahead of myself. 4 pi r squared, and cut that in half for the hemisphere. So once you multiply that in, you end up getting 1/2 times 4 is 2 pi r squared. Then we're going to add on the base, or this is the circle, area of the circle. We know the area of the circle is equal to pi r squared. So if you imagine there's a 1 in front of this, because all coefficients that where you don't see one, there's a 1, you could actually add these two up, and you could say the surface area of a hemisphere is actually equal to not 2 pi r squared, but 3 pi r squared. So surface area of a hemisphere is equal to not 2 pi r squared, but 3 pi r squared, okay? Every single time. And let's just do a quick example of this. If we, for instance, made this diameter, or let's make this radius equal to, let's say 6, feet, then we would use this equation. We could just jump straight to this, because then we would have 3 times pi times 6 squared. 6 squared is 36. 3 times 36 is, I believe, 108. So we have 108 pi feet squared. So SA. All right. So there we have it. Spheres and hemispheres for surface area done. If you do have any questions, please ask, and I will see you in the next one. Bye.